There are various categories of transistors that can be used in the microwave signals or in handling the microwave signal. First is low noise transistor. Low noise transistors are mainly called as LNA, that is low noise amplifiers. They are used for a low noise amplification applications. Then low level transistors, they are used for driving IF stages. Then next one is in the power transistors, they are used for driving power amplifier stages, which are used in the microwave communication. All these transistors can be integrated in a ICs. So microwave ICs are the main applications or main devices which can be used in the communication. Now, there are mainly two categories of a microwave ICs. First one is microwave integrated circuit. In this microwave integrated circuit, the transistors and some lumped components are mounted on a chip. And there are transmission lines also. So all these are mounted on a chip. Some transistors are deposited on a chip and some micro lines are deposited on a chip and some lumped component. It is a combination components are mounted on a chip. So it is a combination of lumped components and the microwave transistors. Then second category of a microwave is a monolithic microwave integrated circuit. So here there is a no lump component. Whatever the required resistance, inductance, capacitance, diode, everything is deposited on an IC, on a chip to form an IC. So all transmission lines are also deposited on the chip. So this is called as a monolithic microwave integrated circuit. It is very compact and that is cheap also. Now, if you see the construction wise, the transistor can be divided basically in two categories, bipolar transistors and a unipolar transistor. Now, bipolar transistor means it is having three doping regions, PNP or NPN. Then it is having the conduction of a current will takes place with the help of two carriers, electrons and holes. It is having in a high gain. Other than this, there is a second category that is in a unipolar transistors. Now these unipolar transistors are having one or two doping regions. Then the conduction carriers will be only either hole or electrons will be there, single carrier will be there. It is we are having a large current output. Similarly, it can be operate for a higher frequencies and it is having very low noise figure. It is less noisy device. The unipolar transistors are FET. Now, other than this, while designing the transistor or constructing the transistor, the main thing that we have to consider that is the mobility of the material or mobility of the carrier. Now, to have the transistor, they should have or to work the transistor on a microwave region, it should have a high mobility. The carrier should have a high mobility. So the semiconductor which is generally used for the construction of a transistor is a silicon, which is not used here. The high that is microwave transistors are made up of high mobility gallium arsenide substrate. So gallium arsenide is the basic substrate which is used for the construction of the transistors. Then it can be for a microwave frequency. The transistors which are used, that is Schottky barrier gate transistor FETs. They are also called as MES FET, metal effect semiconductor FETs. They are having the gain in between 10 to 15 dB at an 2 gigahertz. Then the noise figure is less than 1 dB. Then high electron mobility. There are another category of a transistor is a high electron mobility transistor, that is also called as HEMT. It is having the gain 15 dB at an 8 gigahertz and noise figure is nearly equal to 0.4 dB. If we see the noise figure comparison of a MESFET and HEMT, then the noise figure is quite small in a HEMT. So HEMT is very commonly used transistors. Now if you see the construction, then the basic semi substrate which is used, that is a gallium arsenide. It is having source, gate and drain. They are deposited with N and N plus substrate or N plus doping levels. And the metallic leads are there to attach at an output. It is shown at an gate. So this is the construction of a MESFET. Now HEMT. HEMT is a high mobility transistor, high electron mobility transistors. So here the number of labels are changing, but the basic substrate which is used, that is gallium arsenide. So semi-insulating gallium arsenide. Then the electron gas buffer undoped gallium arsenide gaseous buffer is there. So because of that, the mobility of electron increases. The Al gallium arsenide spacer is also used, and it also comprises of source, drain, and gate, three terminals. This completes module number 5 about the transistors. So you can see everything in detail in the link shared by me, NPTEL lecture link shared by me also. But they are not tailor-made according to the syllabus. So I have recorded my own lecture. You can go through, if you want to see in details, you can go through the NPTEL link also shared along with this video. Thank you.